Hello there, and welcome back to the Sleep Science. Tonight, you're not just falling asleep, you're falling forward in the same direction the universe itself seems to prefer. Around you, a mug of tea cools beside the bed, the moon slides through its quiet orbit, and somewhere out there, entire galaxies drift toward deeper stillness. Everything you can touch, taste, or remember is sliding one way, forward, never backward. You could try to stir the tea to make it hotter again, but you know that's not how this place works. You probably won't survive this if you try to fight time's arrow, but don't worry, we'll just glide along instead. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me in the comments where you're watching from and what time it is where you are. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first thing you notice about time is that it's terribly unfair. You can drop an egg and watch it splatter into chaos, but you'll never see the yolk and shell leap back into wholeness. Every second you lose heat, organization, maybe your car keys, and the universe gains a little more disorder. That imbalance is so universal. It has a name: entropy. It's the quiet accountant behind everything that falls apart. You're living inside its ledger right now. Historians still argue whether the first thinkers who sensed the arrow of time were ancient philosophers or modern physicists. The Egyptians wrote about eternal cycles. The Greeks pictured time as circular, reborn with each sunrise. But the modern view, time as a one-way street, began to form in the smoky labs of 19th century Europe. Picture a bearded scientist leaning over brass instruments, steam fogging the glass, muttering about heat. His name was Rudolf Clausius, and he was the first to write down what he called the second law of thermodynamics, that heat always moves from hot to cold, never the reverse. Your cup of tea obeys it perfectly, cooling even as you sip. Here's the funny part. The deeper you dive into physics, the more the equations themselves refuse to take sides. Newton's laws work just as well if you run them backward. If you filmed 2 billiard balls colliding and reversed the tape, you couldn't tell the difference. Time at that level doesn't care which way it goes. And yet, you do. Your heart beats only one direction through its rhythm, your memories pile up only behind you, and your breath exhales warmth that won't return. Somewhere between the perfect symmetry of equations and the messy experience of life, entropy sneaks in and tilts the balance. Think of the universe as a grand buffet of possibilities. Entropy is just a count of how many different ways things can be arranged without changing the overall energy. Order means few options. Disorder means many. There's only one way for your egg to stay whole, but countless ways for it to splatter. Probability does the heavy lifting. Physics simply nods in approval. Every second that ticks past is really just the universe exploring more of its messy menu. It's strangely poetic that the same law that limits your hot tea also drives stars to shine. The sun burns by running downhill energetically, spilling entropy across the solar system like glitter. You, in turn, bask in that downhill flow, borrowing just enough order to stay alive. When night comes, you radiate your borrowed heat back into the dark, and entropy whispers, "Thank you for your contribution." You can almost hear it through the fan's soft drone, a cosmic tax collector humming through the static. A quirky historical footnote. Before Clausius coined the term entropy, some scientists called it the transformation content. Not exactly catchy, right? It took a while for physicists to agree that the universe's steady slide toward disorder could be given a single symbol, S, and a sort of personality. And now, here you are, falling asleep to it. Somewhere, Boltzmann's famous tombstone reads, S equals K log W, the equation that defines the chaos inside every system. He might have smiled to see it whispered as bedtime poetry. Still, debates linger. Historians still argue whether entropy truly causes time's arrow or merely describes it. Is disorder pushing you forward, or are you moving forward and creating disorder by doing so? It's a bit of a cosmic chicken and egg situation, except this egg doesn't have a chance of reassembling. What's clear is that without entropy, there'd be no difference between yesterday and tomorrow. No sense of aging, no narrative, no you. The hum of your room fades into the background. You imagine the world as a great film reel, but the reel itself only moves in one direction because each frame, once viewed, leaves behind a tiny puff of irretrievable heat. Every heartbeat, Every blink, every memory is a minuscule, irreversible act. You're carving an arrow through space-time just by existing. And maybe that's the quiet comfort in entropy. It ensures stories can happen. A world that ran backward would be impossible to live in. Tea would heat itself, ashes would leap into wood, and your childhood photos would develop themselves into negatives before you were even born. Order would never decay, but nothing new could ever form. The messiness you dread, the breaking, the cooling, the unravelling, is also what makes moments possible. So as you lie there, eyes half closed, remember this. The arrow of time isn't chasing you, you're surfing it. The air in your lungs, the warmth of your blanket, even the faint tick of your clock, all of it is entropy in motion. You're part of the universe's single, unstoppable exhale. Your tea is cooled completely now, a faint swirl of vapour still curling from the rim like a ghost of warmth. You watch the motion die away, slower, slower, until the air itself seems to give up on moving. That simple scene, hot liquid meeting the indifferent chill of your room, isn't just domestic boredom. It's the second law of thermodynamics, performed in miniature. Every time heat spreads out, every time energy evens itself, time steps forward. You can almost hear it ticking in the faint hiss of cooling porcelain. In the language of physics, the law is deceptively plain. Energy tends to flow from concentrated to dispersed, from organised to random. Once that happens, there's no natural way back. The order you started with is gone, spent like coins at an all-night diner. You could reheat the tea, yes, but only by burning more fuel, creating more entropy somewhere else. The universe keeps the books balanced with ruthless precision. You get comfort, it gets chaos. Somewhere in the 1850s, when railroads screamed across Europe and the Industrial Revolution had turned coal into the smell of progress, a few scientists began to wonder why steam engines couldn't be perfectly efficient. They kept noticing the same thing. Some energy always slipped away as heat. Out of that frustration grew a whole field, thermodynamics, and with it, the dawning suspicion that time itself might be linked to waste. There's something darkly funny about that. Humanity's greatest technological leap accidentally revealed the cosmic direction of time. The first law, the one everyone loves, says energy can't be created or destroyed. The second law, the one people ignore until their tea gets cold, says energy will always spread. And it's this spreading, entropy, that gives you a before and an after. You remember pouring the tea, but not some future version of yourself who never poured it. Entropy gives memory a reason to face backward. Historians still argue whether Clausius really understood the philosophical bomb he'd dropped. Some say he was merely describing heat engines, not rewriting the nature of existence. Others insist he glimpsed something deeper, that every irreversible event from melting ice to aging skin points toward an ultimate cosmic exhaustion. Either way, the second law quickly escaped the lab and began haunting poets and philosophers alike. Even your body obeys it with exquisite choreography. You eat structured, low-entropy food, neat little packets of chemical potential, and convert it into motion, warmth, and thought. In the process, you scatter heat everywhere, increasing the entropy of your surroundings far more than the order you built inside. You are, in the nicest possible sense, an entropy machine disguised as a person. There's a quirky bit of trivia here. In 1865, Clausius summarized the laws of thermodynamics in a sentence that reads like a Zen koan. The energy of the universe is constant. The entropy of the universe tends to a maximum. It's the closest thing physics has to a cosmic mantra. Every time you breathe out, that maximum inches closer, though you'll never live to see it reached. Lucky you. You picture the universe as a giant dance floor. Every atom is a dancer bumping into others, exchanging energy, spreading it around. At first, the music is structured, ordered, patterns and rhythms. But as the night drags on, the crowd gets messy. No conductor, no beat, just motion dissolving into noise. That's entropy at work. The night can't unparty itself, and you, somewhere near the snack table, are both participant and witness. It's strange how easily we mistake entropy for decay when, really, it's just change without rehearsal. Think of snowflakes melting on a window, their intricate six-fold symmetry collapsing into droplets that know no pattern. Each flake's death is a tiny act of compliance with the second law, and yet it's beautiful. Nature doesn't apologize for the mess, it leans into it. Not all scientists agreed at first. Some believed the second law was a statistical illusion, a matter of human perspective. Maybe, they said, if you zoomed in far enough, every process could run backward. But no one could catch such a reversal in action, not even under perfect lab conditions. The law kept holding, stubborn as gravity, even as it whispered, "Nothing lasts." And yet, paradoxically, this endless drift toward disorder gives rise to all structure. The sun's heat powers the wind drives waves, waves erode mountains, and in that ceaseless churning, new forms appear. Entropy doesn't mean nothing happens, it means everything happens once. You imagine, for a moment, a universe where the second law were reversed. Energy would clump instead of disperse. Cold coffee would spontaneously heat itself, raindrops would leap upward, corpses would rise and dust would form into living trees. You could theoretically remember the future, but there's a reason you can't picture it clearly. Your brain's wiring was built in a one-way world. Even imagination is bound to the arrow of time. As your breathing slows, you start noticing the symmetry of the small things, the ticking of a clock, a metronome of entropy, the rust on a forgotten key, metal slowly trading its structure for stability, the soft warmth leaving your fingertips, molecules vibrating into the night air. Each moment is a tiny thermodynamic transaction. You live in a constant exchange between order and release, like a musician strumming chords into silence. There's one more joke hidden in all this. You think of disorder as something negative, messy desk, tangled cables, existential dread, but the universe seems to prefer it. It's the state with the most possibilities, the widest menu of arrangements. Entropy, in a sense, is freedom. You might lose your tidy cup of tea, but in return, you gain a universe that can move, evolve, and dance. So, as you stare at the fading steam, realize that what you're seeing is not just cooling. It's the fundamental act of time moving forward. Energy spreads, atoms relax, the future becomes inevitable. The second law isn't your enemy, it's your metronome. Without it, there would be no rhythm to your days, no flow to your memories, no warmth to drift away under. You take one last breath, slow and steady, and for a heartbeat, it almost feels like you can sense the whole universe exhaling with you. An endless, invisible sigh, one that started long before you and will continue long after. You find yourself standing in imagination beneath the soft gaslight of a late 19th century lecture hall. Chalk dust hangs in the air like mist. A nervous man with bright eyes and an unkempt beard steps to the front of the room, clutching notes smudged with sweat. His name is Ludwig Boltzmann, and though he doesn't know it yet, he's about to gamble his sanity on a dream that the arrow of time, the reason your tea cools and never uncools, can be explained by the invisible dance of atoms. You lean forward in your seat. He begins to speak in a heavy Austrian accent, lines of equations spilling across the board. Entropy, he says, is not just about heat. It is about possibility, he gestures wildly. The more ways a system's atoms can be arranged without changing its total energy, the higher its entropy. The students blink. A few scribble furiously. One in the back stifles a yawn, just like you're doing now. Boltzmann lived in a time when atoms were controversial. Many physicists thought matter was continuous, like butter spread across space. Invisible particles, too speculative. But Boltzmann bet his entire career on them. He believed every grain of disorder, every flicker of heat, came from the ceaseless motion of countless microscopic collisions. The universe, in his view, wasn't decaying, it was counting. Here's the famous piece of his puzzle, S equals K log W. You've seen it already, maybe without realizing how audacious it was. S stands for entropy, K for Boltzmann's constant, a tiny bridge between the microscopic and the macroscopic, and W for the number of possible microstates that give rise to the same macrostate. Translation: entropy measures how many hidden ways things can be arranged while looking, to you, exactly the same. A deck of cards is his favourite metaphor. Imagine a brand new ordered deck. Aces through kings, neatly stacked. That's low entropy. Shuffle once. You've already created trillions of possible arrangements. Keep shuffling, and the odds of returning to the original order become so absurdly small you could wait longer than the age of the universe. That's why you never see your coffee unstir or your eggs leap back into shells. They could, mathematically, but the number of paths leading to that miracle is so tiny it might as well be zero. Historians still argue whether Boltzmann's statistical approach really solved the mystery of time's direction, or merely disguised it in math. Some say he replaced one riddle with another. Why was the universe ever ordered enough in the first place for entropy to increase? Others point out that his equations describe probabilities, not certainties, leaving a door, however small, open for reversals. But in daily life, probability is destiny. Boltzmann's brilliance came with a shadow. The more he defended his atomic vision, the more isolated he became. Many of his contemporaries, including the influential Ernst Mach, mocked him publicly. One newspaper caricatured him as a juggler tossing invisible marbles. Imagine working your whole life to prove that the marbles exist. That pressure gnawed at him. The quirky detail no textbook likes to mention. Boltzmann would take long walks by the sea, murmuring to himself, calculating entropy and the rhythm of the waves. His students followed at a distance, half concerned, half inspired. In 1906, while on holiday in Trieste, Boltzmann ended his own life. His tombstone carries only one inscription, S equals K log W. The equation that outlived him, carved in stone, bridging order and chaos, is both a memorial and a punchline, the universe's most elegant eulogy. You linger on that beach with him in your mind. Waves roll in, each crest collapsing into foam. Every splash is a perfect metaphor for his theory. Countless molecules rearranging themselves in endless permutations, never exactly repeating. Entropy plays in the surf, tireless, impartial. You almost wish Boltzmann could have seen how right he was. It's hauntingly poetic, isn't it? That the man who quantified disorder struggled against it internally. But his legacy reshaped physics. His statistical insight became the language of thermodynamics, chemistry, even information theory. Every time you use a computer, somewhere deep in its circuits, bits flip according to probabilities that echo Boltzmann's ghost. You take a slow breath, the kind that barely moves your chest. The air feels heavier now, as if history itself carries weight. Boltzmann's story isn't just about atoms. It's about faith in unseen order. The courage to claim that beneath chaos lies pattern, even if you never live to see it proved. And because you're listening in the dim light somewhere between wakefulness and dreams, you start to notice how this idea mirrors your own life. Every choice you make, every heartbeat, every stray thought, each one a configuration among countless others that could have been. The world around you keeps shuffling, expanding into possibility. You can't reverse it, but you can watch, amazed, as it plays. There's even a fringe idea, half joke, half nightmare, that Boltzmann's own math allows for Boltzmann brains, random conscious minds popping into existence out of pure chaos, complete with false memories of a past that never happened. In a universe infinite enough, such accidents are inevitable. You might be one now, dreaming yourself into existence for just this moment. But don't panic. That kind of speculation belongs to cosmologists with too much coffee and not enough sunlight. Still, you can't help but smile at the absurdity. Entropy means the universe forgets its details over time, and yet here you are, remembering his name. Boltzmann lost to despair, but his atoms won the argument. The second law kept its course, and the arrow of time flew onward, carrying his ideas like pollen through the centuries. Outside your imagined lecture hall, dawn is beginning again. The world grows a fraction more disordered with every sunrise, and somehow that's comforting. If even stars and physicists fall apart, you're in good company. Boltzmann's dream in the end is yours too, to find meaning in the drift, to see beauty in the inevitable spread. So you step away from that chalk-dusted room, back into your own space, where air hums quietly and clocks tick one way. Somewhere, a kettle boils, more entropy in motion, and you whisper, maybe aloud, maybe only in thought, S equals K log W. The softest prayer to an indifferent but comprehensible universe. You sit on the floor, a deck of cards fanned out before you. The air smells faintly of dust and paper, that odd scent of time itself. You pick up the deck, give it a lazy shuffle, and suddenly, without realizing it, you're holding a microcosm of the universe in your hands. This simple act of mixing suits and numbers mirrors the grandest processes in nature. From the swirling of galaxies to the diffusion of ink in water, entropy isn't some distant cosmic abstraction, it's right here between your fingertips. As you riffle the cards, the sound is soft but final, like rain on a tin roof. Each shuffle is an irreversible act. Once you mix them, the odds of getting back to the exact order you started with are astronomically small, about 1 in 10 to the 68th power. For comparison, there are only about 10 to the 80 atoms in the observable universe. You'd have to shuffle almost forever to get back where you began. That's entropy in motion, the proliferation of possibilities, the spread of uncertainty. It's funny, isn't it? You can define the direction of time by a deck of cards. The act of shuffling marks a before and an after. You can remember the pristine order you began with, but not the future pattern the next shuffle will bring. Memory follows the arrow of entropy, just like everything else. Historians still argue whether this probabilistic picture really explains time's arrow or simply describes our helplessness within it. Maybe the universe doesn't prefer disorder. It just explores every arrangement until all have been visited, and the ones with more combinations inevitably dominate. It's less destiny than arithmetic. The math doesn't care about your intuition. It just counts the ways things can be. You stare at the cards again. Somewhere in that stack is the exact sequence you started with. Aces to kings in neat order. But finding it is statistically impossible. And yet, you know it exists. Entropy doesn't erase possibilities. It just buries them under mountains of others. The past is still technically possible. It's just infinitely unlikely. That's the secret link between a deck of cards and a dying star. Both are systems tumbling toward higher entropy, trading structure for probability. A star fuses hydrogen into helium, releasing energy, spreading heat. A deck shuffles into chaos, spreading information. The logic is the same. Once you start the dance, the universe doesn't bother with rewind buttons. There's a curious historical tidbit here. In the early 1900s, a few mathematicians, J. Willard Gibbs among them, realized that you could describe the universe not as a definite set of positions and velocities, but as a distribution of possible states. Instead of saying, this card is here, you'd say, this card has a certain probability of being anywhere. That statistical view became the foundation of modern thermodynamics and later quantum mechanics. Reality, it turns out, isn't deterministic so much as statistically confident. You might smile at how absurdly human it is that we crave order when the universe's most natural state is chaos. We line up our furniture, alphabetize our books, and plan our weeks down to the minute. Yet the moment we stop tending to things, dust settles, socks disappear, memories fade. Entropy is the silent roommate you can never evict. There's even a fringe experiment you can try in your head. Imagine recording yourself shuffling cards, then playing the video backward. Would you spot the reversal instantly? Probably. The sound of the cards snapping would be subtly wrong. The physics would betray itself. Entropy's arrow leaves a visible signature in motion, a bias so deep you can feel it even when you can't measure it. And yet, if you could zoom down to the scale of individual atoms, you'd find a shocking symmetry. Each collision, each vibration, follows reversible laws. The micro-world doesn't care about direction. It's only when you step back, when billions upon billions of interactions pile up, that the arrow emerges. Entropy isn't a force, it's a pattern born from crowds. There's a playful side to all this chaos. Artists and mathematicians both adore randomness, using it to create beauty. Think of Jackson Pollock's splattered canvases or modern musicians generating melodies with algorithms. Each relies on entropy as a collaborator. Disorder, in its way, births novelty. The same law that makes your coffee cool also makes your creativity possible. You're participating in the universe's greatest remix project, even as you drift towards sleep. You tap the top card, the Ace of Spades. Iconic, dramatic, a little fatalistic. You imagine flipping it over, then another, and another, until the table becomes a mosaic of chance. Every pattern is temporary. Every arrangement is just one heartbeat in the long pulse of the universe exploring itself. Historians still debate whether Boltzmann fully understood how profound his statistical ideas would become. Some say he glimpsed the entire cosmic deck being shuffled endlessly, each hand representing a new universe. Others insist he was simply trying to make sense of gases in boxes. Either way, the metaphor stuck. The universe, like your deck, is mostly randomness, with the occasional pattern that feels like meaning. You sigh, slow and deep. The cards lie still now, unthreatening. Somewhere beyond your quiet room, entropy continues its work. The air molecules drifting apart, the Earth radiating heat into space, the Milky Way slowly losing its shape. Yet for this moment, you've paused the game. The arrow of time still moves, but softly, almost kindly, letting you rest within it. One last shuffle, then you set the deck aside. You look at the jumbled faces and instead of frustration, you feel gratitude. Without disorder, nothing would ever change. Without shuffling, no new hands would ever be dealt. The universe needs its randomness just as you need your dreams. You close your eyes for a moment, and the cards fade into the blur of memory. Faces, suits, shuffles all dissolving into that inner fog where yesterday lives. You can still recall the neat order they once held, but not the random patterns you'll make tomorrow. That imbalance, the ability to remember the past but not the future, isn't just a trick of biology. It's entropy, playing puppet master inside your skull. Your brain, after all, is a thermodynamic machine. Every thought, every recollection, every half-formed image of your morning coffee cooling requires energy and leaves behind a trace of heat. Tiny electrical signals race through the folds of grey matter, releasing warmth the way a computer does when it processes data. Each act of remembering increases entropy slightly more. Ironically, your memories of order are themselves little bursts of disorder. There's a mainstream theory in neuroscience that links this directly to the arrow of time. When you experience something new, your brain rearranges molecules and strengthens certain neural connections. That process consumes energy, which flows in one direction, from stored chemical potential to dissipated heat. You can't unfire a neuron in exactly the reverse pattern, because the microstates involved are already scattered. Memory, by its very design, is irreversible. Historians still argue whether human consciousness truly feels time's arrow, or merely rides along with it. Ancient philosophers once thought memory was like etching in wax, a literal imprint of the past preserved intact. Modern science says it's more like ripples on a pond, fading and distorted as new waves pass through. Each recollection you summon slightly overwrites the original, each retelling is a reshuffle of the mental deck. The more you remember something, the further it drifts from what actually happened. You think back to childhood, maybe a bike ride, a smell of summer pavement, the sound of cicadas. You can remember the scene vividly, but you can't predict the next one with the same clarity. That's entropy at work in cognition. The information you've already processed is neatly organized, while the future remains a cloud of uncollapsed probabilities. Your brain runs on the same rule as the cosmos. It prefers moving from uncertainty toward equilibrium, never back again. There's a quirky, almost poetic twist to this. Some researchers have suggested that dreams might be the brain's nightly act of entropy management, a way of shuffling neural cards to prevent overload. While you sleep, fragments of memory dissolve and recombine, making room for tomorrow's experiences. It's as if your mind understands the second law instinctively. Too much order up there and you'd freeze, unable to adapt. Too much chaos and you'd lose coherence entirely. If you could somehow reverse entropy inside your brain, you might be able to remember the future. Imagine waking with tomorrow's memories already printed behind your eyelids. The taste of breakfast not yet cooked. The sound of a conversation that hasn't happened. It sounds magical, but it would also erase your ability to act freely. Choice depends on uncertainty. A perfectly ordered brain would be a static sculpture, knowing everything, changing nothing. You roll onto your side, half smiling at the irony. Forgetfulness, that thing you curse when you lose your keys, is actually a gift of entropy. Without it, you'd be trapped in an unchanging loop of total recall, no room left for surprise or growth. The universe and your brain share a common mercy. Both allow the past to fade so that something new can emerge. Back in the 1940s, a physicist named Erwin Schrödinger, yes, the cat guy, wrote a small book called What is Life? In it, he argued that living things maintain order by feeding on disorder. He described life as negative entropy, or negentropy. When you eat, learn, or breathe, you're borrowing a little structure from the world around you and exporting chaos elsewhere. Even your memories are built on that transaction. You preserve patterns internally while scattering waste heat into the air. Historians still debate whether Schrödinger's phrasing was more poetic than precise, but his idea stuck. Decades later, information theorists like Claude Shannon realized that the math describing entropy and heat also describes entropy and knowledge. The less predictable something is, the more information it contains. That means every memory you make is a local pocket of low entropy, an improbable arrangement of atoms holding meaning for a little while before it dissolves. Picture your brain as a messy library at closing time. The librarians, your neurons, try to keep the shelves organized, but every new visitor knocks books askew. By morning, the place isn't ruined, it's evolved. The disorder has grown, but so has the collection. That's how you live, accumulating meaning in exchange for energy. A small laugh escapes you, the sleepy kind that barely makes a sound. Even your chuckle follows entropy's script. Air compressed, released, molecules scattering just a little faster afterward. You're surrounded by a universe that remembers nothing yet allows you to remember everything that matters, at least for a while. And maybe that's the real beauty of the arrow of time. It gives memory its direction and life its poignancy. You look back because you can't look forward with certainty. You cherish moments precisely because they slip away. Entropy writes melancholy into the structure of experience, turning loss into motion, change into story. Somewhere, the cards you shuffled earlier still rest on the table, their order forgotten. The air in your room has grown slightly warmer from your presence. Every molecule hums with the record of your being here, a faint thermal echo that will fade into nothing soon enough. The past lingers only as warmth, the future waits as probability, and you, right now, float between them, a temporary island of pattern in an ocean of chaos. You drift backward, not in time, because that's impossible, but in imagination, to the moment when time itself first seemed to begin. It's not really a moment, of course. It's more like an explosion of potential, a bloom of space and energy unfolding faster than comprehension. The Big Bang. You're standing, in your mind, at the universe's cold morning, long before stars, before dust, before memory. The irony is immediate. This fiery birth wasn't chaotic at all. It was startlingly, unbelievably ordered. That's the cosmic puzzle. If entropy is supposed to increase with time, then it must have started low, uncomfortably low. The early universe, according to every telescope and equation, was astonishingly smooth. The temperature difference from one point to another was less than 1 part in 100,000. Smoothness might sound like disorder, but in physics it's the opposite. A perfectly even gas, spread uniformly, holds remarkably little entropy compared to the tangled structure of galaxies we see today. So from the very start, the arrow of time was baked into the recipe. The universe began tidy and has been wrinkling ever since. Historians still argue whether that initial neatness demands an explanation or simply is. Some cosmologists insist it points to a deeper principle, perhaps something beyond known physics. Others shrug and say, that's just the boundary condition, don't overthink it. But you can't help it. You stare into that imagined brilliance and wonder why the universe started in such an improbable state, when probability itself prefers chaos. A mainstream fact. About 13.8 billion years ago, the universe was hot enough that matter and radiation were indistinguishable. You wouldn't have survived a microsecond there. Your atoms hadn't even been invented yet. And yet, even in that fury, entropy was relatively small. As the cosmos expanded and cooled, disorder began to grow. Gravity, that patient sculptor, pulled matter together into stars and galaxies, paradoxically increasing entropy by forming structure. It sounds backward, but the math is clear. Clustering allows energy to flow more freely, which means more possibilities, more entropy. You float mentally through those early eons. Hydrogen forms, then helium, the first stars ignite, and suddenly, entropy has its favourite new hobby, fusion. Each star is a factory converting order into light and waste heat. You might think of it as cosmic cooking. The universe started as raw batter, now it's baking itself toward completion. There's a fringe but fascinating tidbit. Some physicists propose that before the Big Bang, there might have been another universe contracting in reverse, a mirror realm where time flowed backward relative to ours. When it collapsed, the entropy of that universe reached a minimum, setting the stage for ours to begin at maximum order. Two arrows of time diverging from a shared moment, like twin rivers running in opposite directions. It's speculative, yes, but deliciously poetic. You could almost imagine someone on the other side dreaming you into existence while they fall backward through what they call their own future. You shift slightly under your blanket. The fan hums a steady rhythm, your personal soundtrack to cosmic expansion. It's humbling to realize that every breath you take carries the legacy of that low-entropy dawn. The carbon in your body was forged in stars, the oxygen in your lungs shaped by fusion. You are, in a literal sense, recycled sunlight. And the fact that you exist, structured, warm, alive, means somewhere else. Entropy increased to make room for you. Historians still debate how we should interpret this ancient asymmetry. Did entropy define time, or did time define entropy? Maybe they were born together, inseparable twins emerging from that initial spark. What's certain is that every event since, the cooling of your tea, the crumbling of empires, the fading of starlight, traces back to that one improbable beginning. You imagine holding the early universe in your palm, a seething ball of uniform energy, so bright it casts no shadows. It doesn't yet know time, it only knows expansion. Then, like a slow exhale, irregularities begin to form, tiny fluctuations, quantum wrinkles magnified by inflation. Those specks of imbalance are the seeds of everything. Galaxies, planets, you. They all sprout from imperfections. Entropy, in its quiet wisdom, needed just a hint of asymmetry to start its eternal climb. It's funny to think that order, the thing we associate with perfection, is actually fragile and short-lived, while disorder is robust. Left alone, the universe always drifts toward the latter, and yet that drift allows order to exist temporarily. If everything stayed in equilibrium, nothing could happen. Stars wouldn't burn, atoms wouldn't bond. You wouldn't be here wondering about any of it. Entropy doesn't just destroy, it enables the story to move forward. You picture the cosmic timeline as a long scroll rolling out before you, inked with increasing complexity, galaxies forming, black holes feeding, civilizations flickering like fireflies. At each step, the entropy climbs. The universe is aging not like a person, but like a song, each note spreading the melody thinner, softer, until only silence remains. A quiet joke comes to mind. The Big Bang was just the universe trying to get comfortable. It started too tight, too smooth, and had to stretch out, sighing into disorder until it could finally relax. Somewhere, a cosmologist might roll their eyes, but the metaphor holds. Expansion is relaxation on a universal scale. You can almost feel that relaxation now in your own body. Your heartbeat slows. The warmth from your skin seeps into the sheets. You too are releasing tiny bits of energy into the environment, helping the cosmos unwind one breath at a time. You're not separate from the Big Bang. You're one of its ongoing ripples, and as your mind begins to drift again, you recognize the strange comfort in that. Everything that has ever existed, every planet, every song, every fleeting thought, was once folded into a single, low-entropy beginning. Time's arrow was drawn there, in that simplicity, pointing outward into complexity and decay. It's not tragedy, it's direction. The tea cools, the stars age, the cards remain shuffled, and you, just another small pattern in the great expansion, slowly dissolve into the same rhythm. Not vanishing, just blending, like the universe itself continuing its long, patient exhale. You hover now between two kinds of ticking, the physical one of your bedside clock and another, softer one, psychological, internal, stitched into your perception. They don't always keep the same rhythm. You might sit through a 2-hour lecture that feels endless, then blink through a 2-hour conversation that feels like minutes. That elasticity is the first clue that there's more than one sort of time unfolding in you. Thermodynamic time belongs to the universe. Psychological time belongs to the mind that's trying to make sense of it. Outside, the cosmos keeps its steady downhill slide, heat dispersing, particles colliding, entropy humming its lullaby. Inside, you mark moments differently. Your brain strings snapshots together and calls it flow. Every memory you make depends on irreversible chemical change, yet your experience of that change is subjective, stretchy, emotional, occasionally ridiculous. You notice it most when you're bored, or anxious, or in love. In those states, entropy doesn't seem to matter. Minutes either crawl or vanish. Time in your mind is a negotiable contract. Historians still argue whether ancient civilizations grasped this duality. The Mayans saw time as a circle. Medieval monks tried to discipline it with bells. Then came the Industrial Age, which stuffed hours into factory whistles and train timetables. By the 19th century, thermodynamic time had won. The second law ruled industry and astronomy alike, turning the once spiritual flow of moments into a measurable drain of energy. Psychological time, however, never signed that treaty. It still sneaks off to daydream when the clock insists otherwise. A simple example, you decide to boil water for tea. Physically, entropy rises. The heat from the burner spreads through the pot into the kitchen air, but in your awareness, there's anticipation, maybe impatience. Subjectively, those few minutes dilate, stretching wider than the physics allows. Then, when the kettle sings, your focus shifts and suddenly the weight feels tiny, almost comic. Your brain edits the record. It's a private, self-authored version of the second law. Mental energy flows from curiosity to satisfaction, irreversible yet unpredictable. Neuroscientists like to say that your perception of duration comes from memory density. Moments packed with change, new sights, new feelings, get stored with more detail so they seem longer in retrospect. Routine stretches of sameness barely leave a trace and shrink when recalled. Entropy increases evenly in both cases, but consciousness weighs them differently. You could live 2 identical hours thermodynamically, and one would feel far richer because you noticed more. There's a quirky modern study about this. Researchers tracked volunteers walking through city streets versus identical routes inside a virtual reality simulation. Both lasted 10 minutes, both consumed roughly the same biological energy. But participants consistently felt that the virtual walk was shorter. Why? Less sensory variety. Their minds produced fewer novel memories, fewer tiny packets of mental order. Psychological entropy, your brain's measure of unpredictability, had fallen. You literally compress time by reducing surprise. It's the only time machine science has managed so far. Boredom. The difference between the universe's clock and your own explains a lot about human behavior. You chase excitement to stretch subjective time. You crave rest to let it shrink. Meanwhile, the cosmos remains unimpressed, adding up all your adventures as identical increases in disorder. It's as if you and reality share a currency, but disagree on exchange rates. Historians still debate whether Einstein's theory of relativity deepened or dissolved this divide. His equations showed that physical time bends with speed and gravity. Clocks run slower in motion or near massive objects. Psychological time, though, bends with emotion. You can't see either distortion directly, you only trust the aftermath. A spacecraft orbiting a black hole and a teenager waiting for a text. Both experience time dilation, but only one requires NASA funding. You remember a day that felt endless, the kind where sunlight crawled and every minute seemed aware of itself. Later you tell someone, that day lasted forever. Of course it didn't. Your molecules aged at the normal rate, your entropy increased on schedule, but inside your mind staged its own rebellion. Maybe that's its quiet strength. Though you can't stop thermodynamic time, you can still bend its perception, carving comfort or suspense out of the same immutable flow. There's a fringe philosophical idea called block time, which claims all moments, past, present, future, exist simultaneously, like pages in a completed book. We only feel a direction because consciousness flips those pages sequentially. If that's true, then psychological time is the reader, thermodynamic time the binding. Entropy would simply mark how far along you've read. It's a strangely soothing thought. The story's already written, but you still get to turn each page at your own pace. You breathe slowly, syncing with the faint ticking in the room. Somewhere in your body, chemical clocks keep time more faithfully than any wristwatch. Heartbeats, circadian rhythms, cell divisions. All of them flow one way because energy always does. Yet your sense of the present, that shimmering now, is only a few seconds wide, a mental buffer the brain stitches together so you don't feel like a flickering slideshow. Entropy may set the tempo, but you provide the melody. As you lie there, that thought becomes oddly comforting. You and the universe aren't enemies moving in opposite directions. You're partners in a duet. It handles the irreversible thermodynamics. You handle the storytelling. The cosmos forgets as it expands, and you remember just enough to make the forgetting meaningful. Your heartbeat ticks forward. The clock ticks forward, but inside, time stretches and contracts like a quiet tide. Entropy hums in both, steady and patient, waiting for you to drift wherever the next second leads. You lie still, watching the faint pattern of light shift on your ceiling, and for a moment you try to imagine a universe without preference, a place where time could run forward or backward, and no one could tell the difference. Equations would love that world. Newton's laws, Maxwell's equations, even quantum mechanics at the microscopic scale, they all work perfectly well in either direction. If a billiard ball rolls right, it can just as easily roll left. Physics, on paper, is polite enough not to take sides. Yet your body, your memories, your heartbeat, all of them rebel against that neutrality. Your life is irreversible. You can't unbreathe the air you've just exhaled. You can't unburn a candle, unmix cream from coffee, uncry a tear back into the eye it came from. And yet, the math doesn't forbid any of it. It merely says it's so improbable you'll never see it happen. Somewhere between theory's symmetry and reality's stubborn one-way street lies the mystery we live inside. Why does the universe allow reversibility in its rules, but not in its results? Historians still argue whether this tension first dawned on scientists through philosophy or frustration. It might have been Isaac Newton himself who first realized his celestial mechanics didn't care which direction time flowed. 2 centuries later, James Clerk Maxwell, whose equations describe electricity and magnetism, noticed the same thing. The problem gnawed at physicists like a loose tooth. If the microlaws are reversible, why is macroscopic life not? Why can you rewind the equations but not your breakfast? Boltzmann's statistics provided a clue, but the discomfort never quite vanished. Even today, some scientists whisper about time-symmetric universes, where everything you experience as decay might, from another vantage, be construction. Imagine a version of you made entirely of reverse processes, breathing in carbon dioxide and exhaling oxygen, growing younger by shedding entropy into the past. You'd exist backward in our timeline, but forward in your own. You wouldn't notice anything odd. For you, coffee would still cool and ice would still melt, just in your direction of time. The laws wouldn't blink. It's bizarre but mathematically consistent. The universe's equations have no built-in arrow. We do. The arrow emerges from initial conditions, the same low entropy beginning you visited earlier. You might say physics gives us the grammar, but entropy writes the story. A curious fringe detail. In the 1860s, a Scottish physicist named William Thomson, better known as Lord Kelvin, argued that heat death, the ultimate equilibrium, would mark the end of time itself. He wasn't being poetic. He meant it literally. When energy stops flowing, when no gradients remain, there will be no measurable difference between before and after. Without change, time loses definition. That's why reversibility isn't just unlikely, it's conceptually empty. A universe that runs backward would still need entropy's gradient to notice the motion. You tilt your head and imagine a simple example. 2 billiard balls collide on a frictionless table. Play the film backward, identical. Now add friction, the faint hiss of air, the warmth of contact. Suddenly, forward and backward aren't the same. Microscopic chaos creeps in, hidden in the countless ways those atoms could vibrate. Entropy has entered the scene, drawing a one-way arrow from symmetry to story. Your heartbeat does the same thing on a grander scale. Every contraction converts chemical order into heat and motion. You can't rewind that. The energy diffuses through tissue into air into space, a wave that never returns. You are, in a beautifully literal sense, an engine obeying thermodynamics, turning structured molecules into warmth, step by step, second by second. Each beat is an irreversible declaration, forward only. Historians still debate whether this irreversibility is fundamental or emergent. Some argue that deep down, hidden beneath quantum fields, there might exist a perfectly reversible substrate where time is just another coordinate. Others believe irreversibility is built into reality itself, a kind of universal bias toward forgetting. You can feel the difference in your bones. No matter how elegant the equations, life refuses to be symmetrical. A favourite classroom trick makes the point nicely. Take a pendulum swinging in vacuum. No air, no friction. It moves forever, perfectly reversible. Add just a whisper of resistance and its arc begins to shrink slowly, gently, inevitably. Energy leaks into the environment as heat, too scattered ever to reclaim. The laws still allow the backward motion, but the universe votes overwhelmingly against it. Entropy wins by numbers, not by decree. That's the subtle humour in our existence. You're built from reversible ingredients, atoms and forces that can, in theory, run either way, but arranged in a pattern so complex that your every breath increases the universe's one-way disorder. You're an asymmetric miracle, a local rebellion that proves the rule. Sometimes late at night, physicists joke that maybe entropy is just a cosmic misunderstanding, a rounding error that makes one direction statistically favoured. But then they look out at supernova remnants, melting glaciers, aging skin, and they laugh quietly. The evidence is overwhelming. The arrow might not be carved into the equations, but it's written all over experience. You shift beneath your blanket, the fabric warm from your body. That warmth is the latest chapter in this story of irreversibility. You can't return it to the atoms that gave it to you. The energy will drift outward, fading into the night air, into the walls, into the endless background radiation. Eventually, some infinitesimal fraction of it will leave Earth entirely, carrying a whisper of your existence into the cosmic microwave sea. There's comfort in that, strangely enough. Even though you can't rewind, your warmth, your movement, your laughter all become part of the universe's irreversible memory. A soft, thermodynamic signature saying, "This happened." You'll never feel it again, but the cosmos does, quietly keeping score. You sigh, the sound small and final like punctuation at the end of a sentence that only flows one way. The air you exhale spreads, collides, mixes. Irreversible, irreversible, irreversible. And somewhere, the equations still hum in perfect symmetry, pretending not to notice. You wander into your kitchen half dreaming, that liminal state between curiosity and fatigue, and there it is again. The everyday miracle that explains the universe, an ice cube sweating on the counter, shrinking into a shimmering puddle. You stare at it as though it's performing for you, which, in a way, it is. The act of melting is so ordinary that you forget it's the same process that drives stars to burn out and galaxies to fade. You lean closer, tracing a droplet's journey as it slips away from the cube's edge. Its path is smooth, inevitable. There's no version of the story where the water suddenly reforms into a perfect cube without intervention. Yet, if you looked closely enough, down to the atomic level, nothing about those molecular vibrations forbids the reverse. The laws of motion could run the film backward perfectly. What stops it is probability, that quiet tyrant named entropy. In the 1850s, Rudolf Clausius introduced a symbol to quantify this tyranny. Delta S greater than or equal to 0, the Greek delta for change, the S for entropy, and the greater than or equal sign marking nature's bias. When a process is perfectly reversible, delta S equals 0. When it's real, like your melting ice, it's greater than 0. That inequality is the difference between ideal and actual, between dream and day. Historians still argue whether Clausius understood how philosophical that tiny sign would become. You rest your fingertips on the countertop, feeling the faint chill radiating outward. Heat is leaving the cube, rushing into your kitchen's warmer air. On paper, the math is simple. Q divided by T, heat divided by temperature, summed across every infinitesimal step. But in practice, it's the whole reason your world ages. Every second, every process trades concentrated energy for dispersed warmth. The second law doesn't shout, it sighs. There's a quirky story about Clausius worth remembering. He once described the universe as a closed system in which entropy always increases, then immediately worried that the phrasing sounded too fatalistic. He added a cheerful caveat. Though the energy of the universe is constant, its entropy tends to a maximum. That single phrase, tends to, is the hopeful part. It implies a journey, not an instant collapse. You and your ice cube are just fellow travellers on that slope toward equilibrium. You imagine zooming in until molecules fill your vision. The cube is a crystalline army of water molecules locked into a tidy lattice. Heat them, and the structure loosens. The molecules gain kinetic energy, trading rigidity for freedom. The system's entropy rises because there are more ways for those molecules to arrange themselves as liquid than as solid. Freedom, it seems, is messy. The cube sacrifices form for variety, order for possibility. Historians still debate whether entropy is truly a measure of disorder or merely of information. How many microscopic configurations produce the same macroscopic state? Either way, the melting ice illustrates both. You can describe it as structure dissolving or as knowledge lost. Before melting, you know precisely where each molecule sits. Afterward, you know almost nothing. Nature trades certainty for flexibility. A small, almost comedic analogy occurs to you. Think of your smartphone's storage. When memory fills up, the system compresses data, deletes duplicates, or dumps the cache. Tiny digital acts of entropy management. Each deleted photo frees space but erases information. The universe does something similar, though on a grander scale. It's constantly reformatting itself, converting neat structures into possibilities. You pick up the glass now, condensation beading against your fingers. The water's cooler than room temperature but already relaxing into thermal peace. You swirl it lazily, watching light distort through it. The shimmering surface becomes a mirror of probability, each flicker a micro-version of the universe evening itself out. Then a thought sneaks in. What if you reversed the movie? Droplets would leap up, fuse, climb, crystallize. You'd hear the faint whisper of heat being absorbed rather than released. For that to happen spontaneously, the surrounding air would need to cool dramatically, giving up energy in perfect coordination. Every molecule in the room would have to conspire. The odds are so minuscule that even the lifetime of the cosmos isn't long enough for a single occurrence. And yet, the equations permit it. That's the strange mercy of physics. It allows what it forbids by sheer improbability. There's a comforting lesson hiding in the puddle's reflection. Equilibrium isn't death, it's balance. When the water and air reach the same temperature, energy stops flowing. The system rests. On cosmic scales, stars seek the same peace. They burn their fuel until gradients vanish, until light and darkness match. Every sunset you've ever seen is just an echo of your ice cube's slow surrender. A soft laugh slips out of you. You realize that the kitchen, with its quiet hum of appliances and faint scent of cooling water, is an unintentional physics lab. The refrigerator in the corner works tirelessly to cheat entropy, pumping heat from inside to outside, paying an energetic price for local order. Its motor clicks, reminding you that every victory against disorder is temporary and expensive. You let the glass sit for a moment longer. The puddle around where the cube once stood spreads thin, catching the light from a nearby bulb. It's no longer dramatic. Entropy's work is done. You wipe the counter with a towel, a symbolic gesture of containment. But the heat the melting released is already everywhere, untraceable. The arrow of time leaves no fingerprints, only warmth. You step back and breathe in. The air feels slightly different, softer somehow. Maybe it's your imagination, or maybe you're noticing entropy's perfume, the faint smell of balance achieved. The puddle is gone, but the energy persists, diffused into the world, one irreversible whisper louder. And as you return to your dim room, the sound of the fridge hums behind you like a tiny sermon. Everything moves forward. Ice melts, warmth spreads, moments dissolve. You can never scoop them back into cubes, but you can watch them with awe. Entropy doesn't demand despair, it invites attention. Every melting thing is telling you a story about how the universe keeps time. You drift far from your kitchen now, beyond steam and puddles and small domestic warmths, into a part of the universe where heat behaves differently, where gravity itself becomes a furnace and information is currency. There, on the event horizon of a black hole, entropy stops being an abstraction and becomes architecture. The black hole hums softly in your imagination, like a cosmic subwoofer, patient and predatory. Everything that falls toward it, light, matter, memory, never returns. And yet, paradoxically, it isn't destroyed. It's recorded. You hover above one of these singular beasts, a patch of warped space-time so dense that even time's arrow seems to stumble. The black hole looks calm, almost serene, its edge marked by the event horizon, a shimmering boundary of no return. Inside, physics stops playing by the usual rules. Outside, the universe still ticks forward. The frontier between those realities is where entropy reaches its most elegant form. It was Jacob Bekenstein, a thoughtful graduate student in the 1970s, who first suggested that black holes must have entropy. Until then, physicists thought of them as ultimate sinks. Things could fall in, energy could go in, but nothing, no heat, no radiation, no information, could escape. That sounded suspiciously like a violation of thermodynamics. So Bekenstein proposed something radical. A black hole's entropy is proportional not to its volume, but to the area of its surface. Every square Planck length of that horizon stores one fundamental bit of information about everything that has ever fallen in. Historians still argue whether Bekenstein truly grasped the depth of his insight, or if he merely stumbled into a prophecy. At first, his idea was dismissed, until Stephen Hawking came along and proved it with mathematics and a mischievous grin. Black holes do radiate faintly through what we now call Hawking radiation. They emit energy, lose mass, and, slowly, over unimaginable time, evaporate. Entropy, it turns out, doesn't die even there. It just waits, whispering across the event horizon. There's something profoundly poetic about it. The universe's most voracious objects are also its greatest librarians. Every particle that disappears into a black hole leaves an imprint on that surface, like letters etched into invisible stone. You could call it cosmic bookkeeping, the grandest manifestation of the second law. The more matter a black hole swallows, the greater its entropy, the bigger its horizon. Even destruction follows a budget. You imagine hovering closer. The closer you drift, the more time stretches. From your distant perspective, any object falling in seems to slow, to freeze just at the edge, never quite crossing. From the object's own view, though, it plunges in freely, gone in an instant. Two truths, both correct, separated by gravity's distortion of time. Thermodynamic time, the arrow you live by, melts into geometry here. Entropy and space-time weave together so tightly that they may, some say, be the same thing. A quirky tidbit. Physicist John Archibald Wheeler once joked, "Black holes have no hair." He meant that aside from mass, charge and spin, nothing distinguishes one black hole from another. Yet decades later, scientists realized he wasn't quite right. The hair, it seems, is the information encoded on the surface. The universe, like a gossip, never forgets. It just stores secrets in the most inconvenient place possible. Historians still debate what happens to that information when a black hole finally evaporates. Hawking himself wavered over the years. If the information truly vanished, it would violate quantum theory, which insists that information can never be destroyed. If it's preserved somehow, it must emerge subtly in the radiation, scrambled beyond recognition. This is the information paradox, one of modern physics' most tantalizing mysteries. Imagine burning a book, then recovering every letter from the smoke and ash if you just knew how to read them. That's the puzzle. The most daring thinkers now whisper that the entire universe might work like a hologram, that everything you perceive as three-dimensional reality is encoded on a distant surface, much like a black hole's horizon. In that view, you're not just living in entropy, you are entropy. You're every moment an arrangement of informational bits expanding outward. It's dizzying, like realizing you might be a page in a cosmic archive. You take a deep breath, grounding yourself in smaller scales. The air in your room feels thin, ordinary, but the same physics applies here. Every breath you exhale carries information, heat patterns, molecular traces, into the atmosphere. If someone knew how to decode every vibration, they could reconstruct your words, your laughter, even this quiet sigh. Nothing is truly lost. It's merely dispersed, encrypted by entropy. That thought isn't frightening, it's comforting. The same law that guarantees disorder also guarantees memory, written in the most permanent ink imaginable. Black holes might be monstrous, but they also promise that existence, once written, cannot be erased. You picture one last scene, the black hole radiating faintly in a cold, distant future, its mass dwindling, its entropy humming one final verse before silence. When it disappears, it will leave behind a mist of pure information, a cosmic ghost, proof that even the deepest gravity well can't swallow time's story entirely. The universe doesn't forget. It just files things away somewhere very dark. You open your eyes again, back in your room. The ceiling looks the same, but for a heartbeat, it feels like an event horizon. Everything that has ever happened written faintly on its surface, invisible yet enduring. Your body is warm, your mind full of traces, and the arrow of time continues its steady descent, carrying all of us toward whatever horizon comes next. You lie there for a while, picturing that black hole horizon fading into static, and then you feel a smaller, more personal hum. the one that runs through your phone, your laptop, the Wi-Fi router's faint heartbeat in the corner. Information itself flowing invisibly through circuits and air is another kind of heat. Each bit flipped from 0 to 1 or back again adds its tiny puff of entropy to the universe. You can't see it, but every Google search and every text you've ever sent leaves a thermal fingerprint, a trace as real as the warmth of your skin against the blanket. In the middle of the 20th century, a quiet man named Claude Shannon sat in an office full of humming machines and noticed something odd. The mathematics that described thermodynamic disorder also described communication. The same formulas Boltzmann had used for gases could measure uncertainty in messages. The link was uncanny, entropy as surprise, as information content. Historians still argue whether Shannon realized he'd just bridged physics and language, but the echo remains. The second law now rules both coffee and code. You picture one of Shannon's examples, a telegraph line sending dots and dashes through noise. The more unpredictable the signal, the higher its information entropy. A perfectly predictable message, ... endlessly, contains no information at all. The system's order is total, but its meaning is nil. That's the paradox. Complete order is sterile. Only uncertainty carries news. The same holds for the universe. Perfect equilibrium would be perfectly boring. A quirky detail. In 1961, physicist Rolf Landauer sharpened this idea into thermodynamic steel. He showed that erasing a single bit of information, resetting a memory from unknown to known, requires a minimum amount of energy, kT-ln2. Even thought has a heat cost. Your computer's fan, whining softly as it clears its cache, is literally obeying the second law. When you hit delete, the system doesn't forget, it warms. You roll that thought around your mind like a pebble. If forgetting releases heat, then remembering must store order. Each memory you make is a small local act of low entropy, balanced by waste heat elsewhere. Your brain, it seems, is a highly inefficient computer, radiating gentle proof of consciousness into the room. Somewhere, Boltzmann is applauding. Information entropy connects elegantly to black holes too, those cosmic libraries you just visited. The bits stored on their horizons are, by Landauer's logic, real physical things. You could, in theory, compute the exact number of fundamental yes-no questions needed to describe the entire visible universe. It's roughly 10 to the power of 90 bits, give or take a few Googles. You, scrolling through a newsfeed, are surfing a very small corner of that cosmic dataset. Historians still debate how deep this equivalence goes. Is information the true substance of reality, with energy and matter merely its expressions? John Wheeler thought so. He coined the phrase "it from bit." In his view, every particle, every field, every flash of light is an answer to a yes or no question posed by the universe to itself. The cosmos, as he imagined it, is not a machine but a conversation. You glance at the soft glow of your phone on the nightstand. It's absurdly poetic, a slab of silicon mimicking the logic of the stars. Each text, photo, and song you store becomes a tiny island of order, constantly eroding under entropy's tide. Even the cloud, our favourite metaphor for digital immortality, is just a warehouse of hot servers somewhere, dumping waste heat into the air. The modern world runs on Boltzmann's ghost. There's humour in that. Every time someone complains that the internet is broken, they're technically right. It's always breaking, in the most fundamental physical sense. Data packets collide, bits flip, errors multiply. The system survives by constantly correcting, cooling, erasing. A global-scale dance against disorder, powered by the same law that melts your ice cubes. You think about your own data trail. Photos, messages, forgotten passwords. Each one feels eternal, but they're all decaying in slow motion, disks demagnetizing, electrons leaking, entropy chewing through memory cells 1 nanometer at a time. Even the digital world has a half-life. The future archaeologists of cyberspace will sift through corrupted files and see entropy's signature written in missing bytes. A tiny smile crosses your face. It's comforting somehow that forgetting is universal. Stars, black holes, hard drives, they all fade the same way. The difference is that you can choose what to remember while you can. Maybe that's what consciousness does best. Curate temporary order in a universe that insists on letting go. You reach out and touch your phone's cool glass. Somewhere inside, electrons rearrange themselves, creating heat imperceptible to your skin. That warmth drifts outward, joins the room's thermal sea, and continues into the night sky. The message you just read, the thought it sparked, both converted into entropy, perfectly accounted for. Nothing wasted, nothing truly lost, just translated into the universe's native language of disorder. As your eyelids grow heavier, you realize information is the gentlest form of entropy, structured chaos, whispering through wires and words. Every heartbeat, every thought, every bit flipped from 0 to 1 is another verse in the same cosmic poem you've been hearing since the Big Bang. Energy dispersing, meaning appearing and dissolving, memory glowing briefly before the fade. And if that feels melancholic, remember that the universe's greatest beauty lies in impermanence. Entropy ensures the story keeps unfolding. Without loss, there'd be no message at all. You wake again, not to an alarm, but to the faint sound of wind moving through leaves, a kind of whispering that sounds, if you listen right, like the universe reminding itself that it's alive. Outside, the trees shimmer and breathe, their ordered green powered by sunlight that has travelled 93 million miles just to lose itself in chlorophyll. You stare, and it hits you. Life itself is entropy's greatest paradox. The very thing that seems to resist disorder survives by accelerating it. Every cell in your body, every leaf in that tree, every ant in its shadow, all are tiny rebels maintaining pockets of order in a world trending toward chaos. But they do it by spending energy, by exporting entropy to their surroundings. You eat, you metabolize, you radiate warmth. The second law doesn't break for you, it just lets you bargain. Erwin Schrödinger was one of the first to frame life in those terms. In 1944, he wrote that living organisms feed on negative entropy, not reversing the cosmic tide but borrowing against it. You absorb organized energy, use it to build structure, then release the excess as heat. You're like a contractor who takes neat stacks of bricks, constructs a fragile house, and dumps the leftover dust into the street. Historians still argue whether Schrödinger's definition captures all of biology, but it's hard to deny the poetry. Life as a local defiance that still honors the universal rule. You stretch, imagining the cells under your skin buzzing like tiny cities. Each one burns fuel, glucose, oxygen, creating microbursts of entropy to sustain its intricate machinery. The mitochondria hum like power plants, pushing electrons through invisible gears. For every atom arranged neatly into DNA or muscle fiber, another dozen scatter their energy outward. You are, from a thermodynamic perspective, a remarkably sophisticated way of spreading heat. There's a quirky historical note here. When scientists first studied living systems through the lens of physics, some accused them of mechanizing the soul. Yet the truth they found was subtler, even more awe-inspiring. It turns out life doesn't defy the laws of thermodynamics, it expresses them. You're not fighting entropy, you're how entropy learns to dance. Consider photosynthesis. Sunlight hits a leaf, and part of that energy gets captured in chemical bonds, turning carbon dioxide and water into sugars. But most of the sunlight, over 95%, bounces away or becomes heat. The plant keeps a little order for itself and gifts the rest to the world as warmth. That's the trade-off written into every living thing. Survival isn't about beating disorder, it's about managing the flow, like a surfer riding a perfect, irreversible wave. You remember from earlier how entropy measures the number of possible microstates a system can take. In that sense, life increases entropy at a furious pace. Every birth, death, breath, and heartbeat multiplies possibilities. The ecosystem around you is an engine of transformation. The forest breathes in carbon and exhales oxygen. Your lungs reverse the process. Entropy grows with every exchange, yet within that constant churn, pattern persists. Historians still debate whether evolution itself is an entropy-driven process. Some argue that natural selection favours complexity because it increases a system's ability to dissipate energy. In that view, intelligence, civilization, even technology are just advanced ways for the universe to burn through free energy faster. The sun provides order, and life obligingly spreads it out. It's not nihilistic, it's magnificent. You, right now, are entropy's most articulate spokesperson, is almost comedic. Every time you tidy your desk or fold your laundry, you're locally reversing entropy, but globally increasing it. The electricity powering your lamp The calories you burn while cleaning all add to the universal tally. Entropy doesn't mind, it rewards the effort with warmth and motion. You could think of it as the universe clapping politely. Nice try, but I win again. Yet you wouldn't want to live in a universe where entropy didn't increase. Without that downhill drive, nothing would ever happen. Stars wouldn't shine, rivers wouldn't flow, thoughts wouldn't form. Entropy gives direction to existence. The trick, as life demonstrates, is to use that direction, to channel decay into creation. You take a deep breath, and suddenly even that act feels miraculous. The oxygen that enters you was stitched together in ancient stars. The carbon you exhale will one day feed a tree. Entropy ensures that nothing stays still long enough to stagnate. In its relentless push toward equilibrium, it churns matter into endless forms, letting order emerge briefly before dissolving again. A quirky tidbit from microbiology. Some extremophile bacteria thrive near volcanic vents, where temperatures exceed boiling. They live by converting chemical gradients, concentrated energy differences, into metabolism. Even there, in hellish conditions, the second law reigns. The bacteria's success depends on their ability to spread heat efficiently. Life, in every form, is a partnership with entropy, not an argument against it. You look out the window again. The sunlight now seems less like brightness and more like a conversation, energy descending, order scattering, photosynthesis whispering back. Entropy, for all its reputation as destruction, is the composer of that symphony. Without it, the world would be static, silent, frozen in perfection. With it, everything moves, transforms, learns, and loves. As you lie back, a faint warmth from the sunlight creeps across the room, touching your skin. You feel like part of a vast feedback loop, absorbing photons that left the sun 8 minutes ago, releasing them later as infrared murmurs. You are entropy in human form, organized enough to marvel at your own impermanence. So when people say life fights against the second law, you can smile softly and know better. Life doesn't fight it, it celebrates it. You are entropy's most elaborate self-portrait, ordered chaos staring into a mirror, admiring the reflection before it fades. You stay by the window as daylight stretches thinner, watching the street outside pulse with quiet, purposeful motion. Delivery vans, cyclists, the rhythmic hiss of espresso machines in a cafe below. Every bit of it runs on energy gradients, fuel combusting, muscles burning glucose, voltage sliding through circuits. Evolution may have sculpted this civilization, but entropy is the architect supervising the project. Life didn't merely survive the second law, it industrialized it. Think of the entire biosphere as one vast thermodynamic machine. The sun pours low entropy energy onto Earth's surface, highly ordered photons streaming from a 5,800 Kelvin furnace, and Earth radiates that energy back into space as diffuse infrared glow. The difference between those two temperatures drives everything: weather, oceans, photosynthesis, even your heartbeat. It's the same trade that powered the first amoeba and now powers skyscrapers. Entropy rises, and life rides the slope. Historians still argue whether Charles Darwin anticipated this connection. He never wrote the word entropy, yet. On the Origin of Species reads like a thermodynamic manifesto. Energy captured, transformed, dissipated through the struggle for existence. Modern biologists have taken the hint. Some propose that evolution's engine, natural selection, favors systems that accelerate energy flow. The more efficiently an organism or ecosystem can spread energy, the more stable it becomes. The same logic applies to markets, cities, and Wi-Fi routers. Civilization is entropy with better branding. You glance at the glow of downtown lights beginning to flicker on. Every bulb, every phone screen is a miniature star, radiating waste heat into the night. Humanity consumes roughly 20 terawatts of power, an invisible halo of infrared entropy bleeding into the atmosphere. From orbit, Earth shines slightly brighter each century, not from enlightenment, but from energy loss. You can almost imagine the planet sighing contentedly, exhaling the day's work. There's a quirky historical echo here. In the 1970s, scientists Ilya Prigogine and Isabel Stengers coined the phrase dissipative structures to describe systems that maintain order by exporting entropy. Hurricanes, ecosystems, economies all qualify. They stay organized precisely because they churn. Your own metabolism is a storm of chemical exchanges keeping you upright by constant burn. A frozen equilibrium would be death. Movement, dissipation, is life's definition of grace. You think about the stock market for a moment. Charts, trades, endless volatility. Beneath its numbers hums the same physics. Energy, in this case, human labour and fossil fuel, feeds the system. Information flows through networks. Heat and waste follow. Money is just a symbolic way to measure entropy's appetite. Every transaction, every product, every streaming video is a little conversion of low-entropy fuel into high-entropy warmth. Economists call it growth. Physicists call it compliance with the second law. Historians still debate how far this analogy can stretch. Some warn against equating thermodynamics with morality. Others see in entropy a kind of ethical realism. The universe doesn't judge, but it insists on accountability. You can't get something for nothing, not even meaning. Every achievement cost energy. Every revelation leaves a heat trail. The candle that illuminates also burns. You take a sip of water and feel it slide down, the same cooling that powered ancient mills and modern turbines. Civilization's genius, really, has been finding endless ways to turn gradients into stories, coal into locomotion, sunlight into harvests, emotional tension into music. Even art, you realize, is entropy's accomplice. The artist converts concentrated thought into scattered feeling. The audience absorbs and diffuses it. Nothing escapes the grand transaction. A soft laugh escapes you. Entropy as patron saint of productivity. Yet there's tenderness in the idea. The fact that beauty, knowledge, and love all require energy to exist doesn't cheapen them. It grounds them. They are real precisely because they fade. The poem must end, the flower must wilt, the power grid must hum and sigh. Without expenditure, there would be no experience. A quirky observation from history. When steam engines first powered factories, some social critics feared they were devouring life. They weren't entirely wrong. Each puff of smoke was entropy spreading. But it also built schools, symphonies, and telescopes. Entropy isn't the villain of progress. It's the ticket price. You rest your forehead against the cool glass. Outside, headlights trace luminous threads across the dark, tiny streams of energy turning chemical potential into motion. Inside, your body does the same, burning sugars to keep neurons firing. From orbit, all of this activity would blur into a faint infrared shimmer. Earth, glowing with industry and biology alike, is a single organism metabolizing sunlight. There's a deeper comfort in that thought. You're part of an economy that spans galaxies. Stars consume hydrogen and emit entropy. Planets catch a fraction and build complexity. Living things use that complexity to replicate, think, and dream. Each layer spends its inheritance of order in more creative ways. Evolution, economy, culture, they're all iterations of the same cosmic business plan. Increase entropy with style. Historians still debate whether humanity could ever run out of usable energy, whether technological ingenuity might cheat the law. But even if we harnessed every photon from every star, the second law would simply nod approvingly. The energy would still flow outward. The universe would still relax. The trick isn't to stop it, it's to make meaning while it lasts. You pull back from the window. The room has cooled slightly, equilibrium finding you again. On your desk lies a notebook, its blank page gleaming faintly. You think of the pen as an entropy engine, ink compressed in its cartridge, waiting to spread across paper. Every word you'll write tonight will be a small expenditure of order, a flicker of energy turned into language. You smile at that, the simplest kind of gratitude, to spend what can't be kept. You sit, pen in hand, and begin to scribble. The page warms under your palm. Somewhere far above, the planet glows a fraction brighter. Entropy keeps its rhythm, and you add your heartbeat to the song. You put the pen down, stretch, and feel the pulse in your fingertips. Tiny electric flickers running through living tissue. Somewhere beneath that biological hum lies another scale of existence altogether. A place where the neat rules of cause and effect loosen, and the arrow of time wobbles. You're descending now into quantum territory, where particles sometimes act as if they remember the future and forget the past. The deeper you go, the slipperier forward becomes. In ordinary life, entropy feels absolute. Heat spreads, glasses shatter, nothing unmelts. But zoom in far enough, and you'll find that the microscopic laws, those that govern electrons, photons and quarks, don't particularly care about direction. Schrödinger's equation, the workhorse of quantum mechanics, is time-symmetric. Run it backward, and it still works beautifully. At that scale, entropy hasn't yet taken the stage. It's waiting in the wings, patient, statistical. Historians still argue whether this realization should comfort or unsettle us. For a while, physicists dreamed that by studying quantum reversibility, they might catch entropy in the act, see how the arrow of time first emerges from symmetry. But whenever they tried to pin it down, the act of measurement itself spoiled the experiment. Observation, paradoxically, is entropy's favourite trick. To know something precisely, you must disturb it. A famous thought experiment proves the point. Imagine a single particle bouncing in a perfectly isolated box. On paper, its motion is reversible. You could calculate its position and velocity backward forever. But the instant you open the box to peek, photons scatter, heat flows, uncertainty blooms. The mere act of looking introduces disorder. Entropy is like gossip. It only grows when shared. You shift in bed, smiling at the absurdity. The universe, it seems, guards its secrets not with locks, but with probabilities. You can know either where a particle is or how fast it's going, never both with infinite precision. The Heisenberg uncertainty principle isn't just about ignorance, it's about the graininess of reality. And because you can't lock both properties down, your ability to reverse any process is fundamentally limited. Entropy slips in through uncertainty's cracks. There's a quirky historical footnote here. In 1961, a young American named John Wheeler proposed the concept of the delayed choice experiment. It suggested that particles could behave as if they knew how they would be measured even after the measurement was made. Later, real experiments confirmed that the decision to observe something as a particle or as a wave can retroactively decide its history. It's not that the future changes the past, it's that, in quantum land, past and future don't mean what they do up here in macroscopic life. Time there is more of a handshake than a march. Historians still debate what these results truly mean. Some say they're mere artifacts of math. Others think they hint that our sense of temporal flow is built on collective quantum forgetfulness. Perhaps entropy is the moment when countless reversible micro-events blur into irreversibility, the way a movie's individual frames blur into motion. Decoherence, as physicists call it, happens when a quantum system interacts with its environment, when information leaks into the wider world, and the delicate superposition of possibilities collapses into one outcome. In that collapse, entropy spikes. You picture it happening in real time inside you. Each time a neuron fires, trillions of quantum events decohere into a definite pattern. An action potential, a thought, a whisper of heat. The arrow of time solidifies right there in your nervous system, a bridge from quantum symmetry to human experience. It's comforting to think that every idea you've ever had is a tiny act of universal direction setting, a declaration that this way forward will do. And yet, there are rare hints that the symmetry still peeks through. Certain subatomic particles, neutral kaons and their cousins, B mesons, have been observed decaying slightly differently forward and backward in time, violating what's called CP symmetry. The difference is vanishingly small but real, as if nature keeps 1 microgram of asymmetry in her pocket, just to prove the arrow isn't entirely statistical. Without that tiny bias, physicists say, matter and antimatter would have annihilated perfectly in the early universe, leaving behind only light. You and everything else solid exist because time itself leans just a fraction of a degree toward one direction. There's a poetic humour in that. The whole visible cosmos born from a microscopic imbalance, like a cosmic coin toss that didn't quite land on its edge. You run a thumb along your bedsheet and imagine that bias rippling through everything. The fabric, the atoms, the faint warmth on your skin. Entropy and asymmetry together form the tide that carries you through existence. Quantum mechanics may allow reversibility, but life refuses it. You can't unread a sentence or unthink a thought. Each act of observation, every photon your eyes capture, is a little bit of order traded for understanding. Awareness is entropy's willing partner, always spending clarity to buy meaning. You roll onto your back and watch the ceiling again. The room feels calm, almost frozen, but you know it's not. Billions of photons are ricocheting between walls. Molecules are colliding, entangling, decohering, obeying their quiet symmetries. Somewhere in all that reversible dance, entropy keeps tally, ensuring that what's known cannot be unknown. A soft grin touches your lips. Maybe time's arrow is less a weapon than a signature, a mark left by countless acts of observation, each sealing possibilities into history. At the quantum level, the universe is undecided. At the human level, it's a story told one irreversible measurement at a time. So you breathe, feel the air fill your lungs, and know that even here, between inhalation and exhalation, the arrow of time is being written in microscopic detail. Every molecule that enters you leaves a little more disordered than it came. You are, in this quiet moment, a bridge between reversibility and the real, a creature of probability turned into permanence. The ceiling above you fades into that half-lit space behind the eyelids, where imagination and reflection mingle, and suddenly you're not just thinking about time, you're feeling it moving through you, like a second heartbeat. You start to wonder whether the same physics that guides melting ice and dying stars also shapes the shimmer of awareness itself. What if consciousness is simply what entropy looks like when it learns to watch itself? Your thoughts drift lazily between philosophy and physiology. Every neural spark you experience costs energy. Every decision you make releases a trace of heat. Those shimmering microbursts of warmth inside your head are measurable, tiny thermodynamic receipts for every moment of choice. Neuroscientists have even caught them in infrared scans, thought as temperature, mind as metabolism. You can almost imagine Boltzmann leaning over your shoulder whispering, "See, even your soul obeys the second law." Historians still argue whether free will can survive that equation. If each choice is just the statistically favoured outcome of neurons obeying chemistry, then you might be nothing more than a pattern of entropic preference, an arrangement that happens to process information in ways evolution found useful. Yet the same historians will admit, often with a wry smile, that no human has ever felt like a machine. Subjectively, choice feels real. Perhaps that sensation itself is the universe's cleverest illusion, complexity mistaking itself for autonomy. You recall the quirky 1980s experiments by Benjamin Libet. Volunteers pressed a button whenever they felt the urge, while electrodes watched their brains. To everyone's surprise, the brain's readiness potential, its unconscious preparation to act, appeared fractions of a second before the conscious decision. The neurons had already started the process before you arrived to take credit. Entropy had already picked its path. Consciousness simply narrated it after the fact. And yet, the story isn't finished. Later studies suggested that awareness can still veto an impulse, stop a finger mid-press, delay a word mid-sentence. Maybe free will isn't the power to start things, but to redirect them, to choose how the inevitable flow of entropy expresses itself. Like a surfer can't control the ocean but can lean, balance, steer. You can't halt the forward rush of disorder, but you can sculpt its momentary form. There's a fringe hypothesis from neuroscience called integrated information theory. It proposes that consciousness arises wherever information becomes sufficiently interconnected, where patterns feed back on themselves faster than they can decay. By that logic, awareness is a thermodynamic structure, a system dense enough to momentarily resist entropy's spread, yet porous enough to let energy flow through. You are a knot in the universe's fabric, tightening briefly before unraveling again. Historians still debate whether the brain's arrow of time is identical to the cosmic one. Some researchers suspect your mind might create its own miniature arrows, localized symmetries of perception stitched together from memory. The past feels fixed because your neurons store traces of it. The future feels open because those traces don't exist yet. Consciousness may not ride time's arrow so much as draw it, frame by frame, in the act of remembering. You shift slightly, noticing the warmth your body has lent to the sheets. That heat is data too, the physical record of thought diffusing outward. There's something beautifully humbling about that. Even your introspection leaves a thermodynamic footprint. Every night your dreams radiate softly into the atmosphere, a whisper of entropy shaped like wonder. A quirky anecdote floats up from memory. In 1967, physicist Freeman Dyson half-joked that intelligence might someday find ways to think forever, stretching thought infinitely even as the universe cooled. But later he admitted the math didn't work. Entropy's decline in a dying cosmos would eventually freeze all processes, including mind. Thought, he realized, depends on waste heat. To think is to burn. Awareness requires its own evaporation. Maybe that's why consciousness feels like a flame, bright, restless, constantly consuming. You spend your days transforming chemical order into ideas, emotions, laughter. Each spark leaves you a little lighter, a little closer to equilibrium. The mind is the only furnace that enjoys its own fading. You recall the saying that memory is the residue of experience. From physics' view, residue is heat, entropy left behind by transformation. Every memory, then, is a tiny patch of cooled possibility, the ash of an event burned into neural structure. Awareness isn't separate from entropy. It's the art of noticing how things fall apart. So perhaps free will isn't about fighting the second law. Maybe it's about interpreting it, assigning meaning to irreversible acts. You can't unspeak a word or unbreak a heart, but you can decide what those moments signify. Consciousness doesn't alter entropy's arithmetic. It writes poetry in its margins. The room is utterly still now. Your breathing evens out. For a fleeting second, you sense the intricate balance inside you. Trillions of microscopic reactions humming in coordinated decay, creating the illusion of a continuous self. Somewhere deep within that thermodynamic orchestra, the arrow of time and the feeling of I are playing the same note. You smile, not because you've solved anything, but because the question itself feels alive. Entropy, free will, consciousness, they're all facets of the same mystery, ordered patterns dissolving gracefully into possibility. And you, just for this heartbeat, are aware of the dissolve. You open your eyes again, though you're not sure how much time has passed. The room is darker now, its edges softened into charcoal grey. Outside, the world has quieted. The night air feels ancient, like the universe rehearsing its own ending. You can almost picture it, the far, far future when the stars have gone cold, when even the galaxies have faded into thin, scattered dust. The horizon of heat death. It's an image so vast it makes your heartbeat sound like thunder by comparison. Every sun you've ever seen, every spark of life, every candle or neon sign, all will eventually run out of gradients to burn. Entropy will have spread so thoroughly that there will be no difference between here and there, now and later. A perfect uniformity. And in that stillness, time itself will lose its meaning. Historians still argue whether this final state is poetic exaggeration or physical inevitability. Some cosmologists accept it grimly, calling it the heat death of the universe. Others cling to alternate endings, cyclic universes, quantum rebirths, or hidden pockets of negentropy waiting to bloom. But the numbers are merciless. The cosmic microwave background cools a little more each billion years, stars die faster than new ones form, and black holes themselves will one day evaporate into soft radiation. The second law is patient. It doesn't rush the finale. You drift inward, imagining the sequence. First the red dwarfs fade, those slow-burning embers that will outlive our sun by trillions of years. Then come the last flickers of white dwarfs, collapsing into silence. Galaxies, stretched by expansion, drift so far apart that no new light crosses between them. Each one becomes an isolated island of darkness. Planets, if any remain, orbit dead suns. Atoms decay into simpler particles. Eventually even protons may dissolve. The cosmos turns into a thin mist of photons, cold even, and utterly at peace. There's a strange comfort in that picture. It isn't violent, it's quiet, almost tender. Entropy doesn't destroy, it completes. The universe will end not in flames, but in sighs, like an orchestra drawing out its final note, every sound resolving into silence. A quirky historical footnote. The term heat death was coined in the 1850s, not long after steam engines first taught humanity that energy had limits. The idea terrified philosophers. One writer described it as the eternal rest of all physical activity, another as the grave of creation. But to modern physicists, it's less a grave than a transformation. Energy isn't gone, it's simply so evenly spread that no work can be done. The stage remains, the lights dimmed, the actors forever at rest. You breathe slowly, matching the imagined rhythm of that far future. The air in your room is warm, comfortable, an island of order in a vast entropic sea. It's strange to realize that even now, while you lie here, The universe is cooling toward that horizon. Every photon escaping your lamp, every sigh leaving your lungs, contributes a microscopic nudge toward equilibrium. You're both participant and witness. Historians still debate what this ultimate equilibrium means philosophically. Does the loss of distinction between past and future imply that time ends? Or does it continue eternally, meaningless but unbroken? Without change, time becomes an empty coordinate, a clock whose hands have stopped but whose face still exists. Perhaps time, like temperature, requires difference to be felt. No gradient, no arrow. And yet, you can't help but imagine what might persist. Some theories hint that quantum fluctuations could still ripple through the darkness, birthing occasional sparks of order, tiny bubbles of low entropy, brief, local reversals that fade as quickly as they arise. Maybe in one of those bubbles something like thought could flicker. Maybe that's all existence ever is, entropy's dream of variety. You smile faintly. If the cosmos is destined for stillness, then every heartbeat right now is a rebellion. Proof that order once danced in the dark. And maybe that's the meaning of living at this midpoint between creation and equilibrium, to marvel at motion while it lasts. The notion of heat death often sounds tragic to us because we equate quiet with absence. But imagine it instead as completion, like a story that finally exhaled its last chapter. The plot is unfolded, the conflicts resolved, the themes explored. What remains is the calm after comprehension, when nothing more needs to happen. Entropy isn't villainous, it's closure. You picture yourself billions of years from now as part of that uniform glow, your atoms long scattered, your energy diffused, yet still present as a faint murmur in the final chorus. Somewhere, a photon that once bounced off your skin travels endlessly, carrying your warmth into eternity. Not memory, exactly, but persistence. The smallest proof that you existed within the universe's great unmaking. It's humbling, yes, but also liberating. The arrow of time doesn't end in despair, it ends in rest. The cosmos will not vanish, it will simply stop needing to change. You exhale, matching that far-off rhythm. The fan hums softly, air moving from high to low pressure, another microcosm of the second law at work. The sound is peaceful, hypnotic. In the flicker between your breaths, you sense the quiet dignity of the universe's long decline, the infinite patience of matter, the graceful surrender of light. If heat death is coming, you think, then so be it. Let it be slow, luminous, full of meaning. Let the arrow of time, after all its striving, find peace. You close your eyes, and for a heartbeat, the silence around you feels infinite, like the first note of that final symphony has already begun. You open your eyes into that hush, and the darkness around you feels almost sculpted. Even silence has texture. The faint hum of the city beyond the window, the grain of the wall catching stray light. You start to notice how everything you call beautiful carries a trace of entropy. Weathered paint, chipped stone, music fading in the air. We dress decay in affection and call it patina. Maybe that's the secret the universe has been trying to tell you. Disorder can be gorgeous. Outside, a street lamp pulls amber light across wet pavement. The reflection quivers with every gust of wind, an accidental painting that will never repeat. You think of ruins you've seen, columns worn by centuries of the rain, mosaics missing half their tiles, castles eroded into skeletons of limestone. Historians still argue whether ancient builders expected their works to crumble or whether they hoped for immortality. Either way, time has added its own artistry, rounding sharp corners into grace. A quirky anecdote floats up. In the 18th century, some European gardeners began building artificial ruins on purpose. They'd construct fake crumbling arches beside pristine palaces because imperfection felt romantic. Entropy became decor. The message was slyly philosophical. Permanence is boring, transience moves the heart. You glance at the artwork on your own wall, a print slightly faded by sunlight. It looks warmer now than when it was new. Pigments have oxidized, molecules rearranged, entropy has collaborated. You realize that even memory works that way. Recollection edits, blurs, fills gaps, turning raw fact into story. The edges soften, and meaning seeps through the cracks. Historians still debate whether our fascination with decay is cultural or universal. Japanese aesthetics call it wabi-sabi, the appreciation of impermanence. Gothic cathedrals, by contrast, were meant to defy it, yet now tourists love them precisely because they're worn. Somewhere between denial and acceptance lies art. You picture an old violin, its varnish crazed, its wood darkened by the oils of countless hands. The sound it makes, mellow, uneven, is entropy turned melodic. Each note you hear is friction, vibration, heat bleeding away. If you froze that process, stopped the losses, the music would vanish. Art exists because the world can't hold still. There's humour in that. Every masterpiece owes a debt to physics. Michelangelo's marble cracked microscopically as he carved. Van Gogh's thick paints slowly polymerize and fade. Even digital art isn't safe. Bits rot, files corrupt. Entropy is the co-author signing every canvas. You walk in your mind through a future museum. A curator explains that the exhibits are allowed to deteriorate intentionally, to keep them alive. The visitors nod. They understand that perfection is sterile, that age is narrative. Somewhere in that gallery, a sculpture made of iron is quietly rusting, and no one wants to stop it. You think of music again, the way a record gathers static, or how a singer's breath trembles at the end of a line. Those imperfections are what make performances human. Engineers can remove noise, but at the cost of warmth. Entropy, in sound, is emotion's fingerprint. Historians still argue whether architecture should resist or embrace this. Modernism once promised glass towers immune to time. Postmodernism responded with buildings designed to weather, to stain, to grow moss. Cities, like galaxies, evolve by erosion. Concrete cracks, steel blooms with rust, and yet skylines shine brighter each dusk because light loves rough surfaces. A fringe tidbit. Some conservation scientists now model the aesthetic half-life of materials, the point at which decay becomes beauty rather than damage. Copper roofs turn green, photographs yellow into nostalgia. The math of corrosion doubles as the math of charm. You let your gaze wander to the ceiling, where faint shadows from the streetlight ripple. Even that play of illumination is entropy in miniature. Photons scattering, air currents bending them. The pattern will never repeat, but for this instant it's perfect. The longer you stare, the more you feel that everything ephemeral contains a kind of mercy. If all things lasted unchanged, nothing would surprise you. The chipped mug on your desk, the wrinkles at the corner of your eyes, the echo of a favourite song, each is evidence that time leaves gifts as well as losses. Entropy doesn't erase meaning, it seasons it. A quiet laugh escapes you. You think of the universe's eventual heat death again and realise it won't be ugly. It'll be the grandest ruin of all. A cathedral of equilibrium, built molecule by molecule from the rubble of every star. Maybe that's why humans build ruins into their stories, to practice awe before the inevitable. You close your eyes and imagine walking through that ultimate museum, where every galaxy has collapsed into memory. The walls are made of frozen light. The exhibits are the faint afterglows of what once was. Nothing moves, yet everything hums with completion. You find it peaceful, not tragic. Even silence by then will have texture. Back in your room, the street lamp flickers once, then steadies. You reach out and touch the cool surface of the wall, the paint, the plaster, your skin. All are slowly exchanging heat, blending toward equilibrium. You smile, tracing the faint crack in the corner. It's not a flaw, it's proof of participation. Entropy, you realize, is not merely the reason beauty fades, it's the reason beauty exists at all. The universe had to learn how to fall apart before it could learn how to sing. You rest your hand against that cracked wall a moment longer, and then, almost imperceptibly, the thought comes. If everything drifts towards stillness, could there ever be a rewind? Could the universe somehow start again? You picture the cosmic film unspooling in reverse, stars reassembling from ashes, galaxies sliding back into a single blaze of density. It feels like heresy against the second law, but physicists have dared to imagine it. They call it cosmological rebirth. Long before our telescopes could see the faint afterglow of the Big Bang, philosophers toyed with cycles, eternal return, cosmic seasons. Ancient Hindus spoke of kalpas, infinite ages of creation and dissolution. The Stoics imagined the cosmos burning itself to purity before reforming identically. Historians still argue whether those myths guessed the rhythm of reality or simply reflected human nostalgia for do-overs. Either way, the idea lingers like a dream, entropy taking a breath in, then out. Modern cosmology, of course, deals in equations, not myths. For a while, the Big Crunch looked promising. If gravity was strong enough, the expansion that began 13.8 billion years ago would eventually slow, halt, and reverse. Galaxies would draw together, temperatures would rise, entropy might paradoxically reset at the singularity, the universe dying into its own rebirth. But then came the discovery of dark energy, that mysterious force pushing galaxies apart faster and faster. The dream of the crunch dimmed, the script tilted toward eternal expansion. Still, the cycle refuses to die. A few physicists, Roger Penrose among them, propose conformal cyclic cosmology. When the universe becomes smooth, uniform and almost empty, time and scale lose meaning. Photons forget distances, big and small become synonyms. In that state, the cosmos might as well be a singularity again, a blank page ready for a new beginning. Each aeon gives birth to the next, not through collapse, but through continuity. The end and the start touching fingertips. There's a quirky footnote to Penrose's theory. He claimed to see faint concentric circles in the cosmic microwave background, relics of black holes evaporating in a previous universe. His critics, of course, rolled their eyes, pointing out that random noise can look like halos if you squint hard enough. Historians still argue whether those circles are evidence or pareidolia, science's version of reading tea leaves in the cosmic static. Yet the thought remains seductive. What if our Big Bang was simply a memory of another's quiet finale? You close your eyes and let that image form, a breathing universe, exhaling entropy until even light forgets how to move, then inhaling again, compressing tranquility into ignition. You can almost hear the cosmic lungs expanding, contracting, infinitely patient. The second law doesn't vanish. It just bends into a circle, allowing order to rise again from equilibrium's ashes. Of course, not all rebirths require entire universes. Stars recycle themselves endlessly. A supernova's death scatters heavy elements that seed new systems. The calcium in your bones, the iron in your blood, they were minted in such explosions. Even now, deep in molecular clouds, gravity gathers dust into embryos of light. The cosmos doesn't rewind, but it does repurpose. Nothing escapes the second law. It simply learns new ways to express it. You think of that, and suddenly life's recycling habits, decomposition, regrowth, memory, feel cosmological. Forests feed on their own decay. Species evolve, die, and return in altered forms. Civilizations rise from ruins left by others. Human stories too repeat. Love, loss, discovery, forgetfulness, all looping endlessly through new faces. Entropy allows continuity by guaranteeing change. A small laugh escapes you. You imagine entropy not as a straight arrow but as a spiral staircase. Each step down in order brings you around again to something familiar, though never quite the same. A melody repeating in a new key. Maybe the universe isn't doomed to silence. Maybe it's composing variations. Historians still debate whether time itself could flip during such cycles. Would memory reverse? Would cause follow effect backward? Or would each new expansion bring its own arrow, fresh and forward, indifferent to the ghosts of previous universes? No one knows. What's clear is that entropy's direction is local. Each new beginning gets its own sunrise, its own logic. There's an almost spiritual symmetry to that thought. The energy you release tonight, the faint warmth from your breath, could, billions of years hence, help form a star, a planet, perhaps a creature wondering how time flows. Entropy isn't waste, it's inheritance. Every ounce of disorder you add to the cosmos becomes material for someone else's order. You picture the cosmic microwave background again, that faint 2.7 Kelvin glow washing over everything. In it might lie the fingerprints of countless beginnings, stacked like translucent pages. You, an ephemeral spark on one of those pages listening to the hum of eternity, trying to glimpse the next. The night around you deepens. The hum of your fan, the faint warmth of your body, the slow radiating of your room into the universe. All of it feels like participation in the same breathing pattern. Expansion, release, pause. Maybe the universe isn't racing toward death. Maybe it's learning to rest between breaths. You let the thought settle. Whether the cosmos ends or begins again doesn't change this moment. the soft entropy of sheets, the whisper of air. What matters is that it moves. The story continues, even if chapters overlap. In the end, perhaps rebirth isn't about escaping entropy at all. It's about recognizing that every ending already contains the next spark. Even decay, at its most complete, hums with potential. Entropy, after all, never stops creating. You're still floating inside that image of the universe breathing when another realization drifts in. Maybe we humans already built our own kind of time machine, not with gears or wormholes, but with something softer. Memory, story, and song. There are small rebellions against the one-way street of entropy, little acts of reversal stitched into the flow of decay. Every time you remember, retell, or hum a melody from the past, you're reaching backward, pulling a moment toward the present before letting it go again. The idea feels fragile and profound. Your mind itself is a device for recycling the irreversible, the way an old record player recovers music from spinning grooves. The past becomes vibration, then warmth, then silence, then vibration again. Historians still argue whether storytelling arose as entertainment or survival instinct, but either way it serves the same thermodynamic function, converting raw experience, chaotic data, into ordered pattern before releasing it back as meaning. You can see it clearly now. When early humans gathered around fires, they weren't just passing the time, they were taming it. The flames turned wood into heat, entropy in action, while voices turned memory into myth. One energy fed the body, the other the mind. Both followed the same law, order spent to create understanding. There's a quirky bit of archaeology about that. In a cave in southern France, researchers found 17,000-year-old paintings of animals, bison, horses, deer, each with faint echoes of motion, as though the artists were trying to show time itself on the walls. They even found evidence that torches were waved while the artists worked, the flickering light making the painted figures appear to move. The first cinema powered by entropy's own dance. You close your eyes and imagine one of those ancient painters, crouched near the wall, hand trembling slightly. The torch crackles, the air shimmers with carbon heat. He's burning energy, literally, to record a fleeting vision. Thousands of years later, you see it and feel that moment flicker again. Time folds inward. Historians still debate whether art truly cheats entropy or just makes peace with it. Some say culture slows the decay of meaning the way refrigeration slows spoilage. Others insist that each performance, each telling, is a new act of entropy creation. Unique, unrepeatable, disappearing as soon as it happens. But that's the trick. Meaning only exists in the moment of loss. The song's beauty lives in its fade. You think about music now, how a melody can resurrect a forgotten afternoon more vividly than any photograph. The tune unspools, vibrating air, warming eardrums, creating structure from randomness. Every note that vanishes leaves a trace of order in emotion. Entropy climbs, but so does connection. That's the hidden symmetry of art. It turns decay into pattern and pattern into memory. A quirky modern echo. Digital archivists joke that the internet is the first afterlife with a loading bar. We upload our photos, our thoughts, our songs, trying to freeze them in silicon. Yet every hard drive hums with heat, every server farm a cathedral of entropy disguised as permanence. Information, as you learned earlier, can never be stored without cost. The stories live by burning electricity. Even eternity needs cooling fans. You smile, thinking of how many times you've reread a favourite book or rewatched a film. Each repetition is slightly different because you are different. The molecules in your body rearranged, the neurons rewired. Entropy ensures that memory and meaning never repeat exactly. The story changes you even as you change the story. Historians still argue whether human consciousness evolved primarily for prediction or narration. Some neuroscientists believe the brain's primary job is to simulate possible futures using fragments of the past. Each imagined tomorrow is a miniature reversal, a way of borrowing entropy from memory to fuel decision. You could call imagination the universe's temporary loophole, a localized time machine powered by metabolism and hope. You glance at your notebook again, the words you wrote earlier glowing faintly in lamplight. Ink drying is chemistry, oxidation, irreversible. Yet the sentences resurrect moments from hours ago. Writing too is thermodynamic sorcery. structured symbols defying the drift towards silence. You burn energy to make language stand still. There's a fringe idea that maybe the entire purpose of intelligence is to preserve information longer than physics allows, to delay forgetting. If so, culture is entropy's mirror. It consumes energy to buy memory a few more heartbeats. Stories, songs, rituals, they're how the universe remembers itself through us. You hum softly now, an unplanned tune looping in your throat. The sound vibrates through your chest, fills the air, then dissolves. The molecules that carried it continue outward, colliding, fading, heating the room by a microscopic fraction. That warmth will spread forever, an acoustic fossil of your voice. Somewhere in the far future, a stray photon might still carry a fragment of that vibration, drifting through the dark. Maybe that's what humans are really doing when we create. We're trying to leave patterns sturdy enough to echo after we're gone, knowing full well they'll fade. It's not immortality. It's participation. You can't reverse the arrow, but you can write your initials on it as it flies. You close your eyes again and picture the long thread of every story ever told, stretching from cave walls to digital screens, glowing faintly against the darkness. It twists and tangles, but it never breaks. Entropy pushes forward. Humans answer by narrating backward. Together they weave time. Outside, wind slides through the trees, turning leaves into applause. Inside, your heartbeat keeps its metronome pace. The song you hummed still vibrates in the air for a few seconds more before it disappears completely. You can almost hear the echo merging with the fan's low sigh, a soft reminder that even in fading there's music. And maybe that's enough. You can't reverse time, but you can replay it. You can't stop entropy, but you can turn it into art. Every memory, every story, every song is proof that forward motion doesn't mean forgetting, it means transforming. You stay still for a long moment, letting that last echo of sound dissolve into the dark. There's something sacred about silence after music. It's the universe bowing politely before it moves on. And maybe that's where acceptance begins, realizing you don't have to outrun entropy, only learn its rhythm. You, the tea that cooled, the deck that shuffled, the star that burned, every bit of matter and thought has been practicing this same lesson for billions of years. Forward is the only direction there ever was, but grace is how you travel it. The room feels lighter now, as though each previous section of this journey, ice cubes, black holes, ruined cathedrals, has been quietly folding itself into you. You see entropy everywhere, and no longer as doom. It's in the curl of a smile line, the smell of rain, the comforting sag of a favourite chair. It's the universe sighing into comfort, settling into itself. Historians still argue whether time's arrow is a curse or a gift. Philosophers keep trying to build machines that erase yesterday's mistakes, while poets have already accepted that mistakes are how meaning begins. Maybe the distinction between tragedy and wonder is simply pacing. Watch long enough, and every fall becomes part of a larger dance. You think of all the small arrows that make up your day, the alarm clock's shrill beginning, the fading warmth of breakfast, the quiet click of lights off before bed. Every one of them points forward irreversibly, yet each contains a cycle. Waking, eating, resting, dreaming. The small reversals that life builds within the grand one-way current. That's the trick of being human. You can't turn the river, but you can swim in loops. There's a quirky historical note that fits here. The physicist Arthur Eddington, who first coined the phrase the arrow of time, also spent evenings composing sonnets about stars. He said equations could describe motion, but only poetry could explain why it mattered. He died in 1944, his notebooks full of numbers and verses side by side. Even the man who named the arrow needed art to aim it, so you try to see your own arrow now, not as something chasing you toward decay, but as a trail you're leaving behind, glowing faintly in the dark. Each breath you've taken tonight has scattered molecules that will drift across continents, oceans, epochs. The carbon from your lungs might someday feed a forest, or form the backbone of a comet, or circle a new star. Entropy guarantees continuation through transformation. You lose nothing that isn't simply changed. Historians still debate what endings even mean in physics. The first law insists energy is conserved, the second insists its quality degrades. Between those truths lies the miracle of existence, constant quantity, infinite variety. The universe never stops, it just changes tempo. You're a brief measure in that symphony, but your note matters because it completes the phrase. You stretch, feeling the warmth you've built beneath the blanket. Even now, your body is doing the universe's oldest work, turning chemical order into peace. You could curse that inevitability, or you could call it devotion, the offering of your stored energy back to the system that lent it. Every living thing does the same, a liturgy of letting go. There's humour in the realisation that the most universal truth sounds suspiciously like self-help advice. Everything changes, accept it. But it's more than sentiment, it's physics. Entropy's promise is that nothing stays frozen, which means pain softens, joy fades into memory, and new moments keep arriving, unasked but miraculous. The arrow of time is the universe's way of ensuring that the story never stalls. You remember Boltzmann, poor, brilliant Boltzmann, carving his equation into history. You think of Clausius with his polite inequality, Shannon with his bits, and the nameless astronomers tracing heat maps of the sky. They weren't chasing despair, they were chasing comprehension. To measure entropy is to fall in love with impermanence. They understood that in the end, knowledge itself is a kind of grace, a way to ride the downhill path with open eyes. Outside, wind moves again through the trees. Each leaf trembles, dissipating energy in a whisper. You listen, and it sounds like applause. Entropy clapping for itself, for everything it's built and broken. You smile, and for the first time tonight you feel the full comfort of inevitability. If time must move forward, let it. If entropy must grow, help it do so beautifully. Write, build, sing, rest. Live as if your warmth is a gift you're passing on to whatever comes next. The universe doesn't need you to endure forever. It only asks you to participate while you're here. So you breathe, one more slow inhale, one more soft exhale. The arrow moves, and you move with it, no longer resisting. You're part of the great unwinding, the gentle slide from order to openness, from structure to possibility. And in that motion, there's peace, the deep, endless kind that doesn't end but dissolves. The fan hums its lullaby, the room cools slightly, and the air feels full of everything that has ever been alive. You close your eyes, following the arrow not as a command but as an invitation. Somewhere beyond dreams, entropy hums the same steady note it has since the beginning, and you hum along perfectly in tune. So now, as you drift towards sleep, let everything you've heard tonight settle softly. The equations and metaphors, the black holes and melting ice, they're only different verses of the same lullaby. Entropy, time's hidden compass, keeps guiding the world forward, and you're part of that flow. There's nothing to fight, nothing to fix. The warmth you've shared with the room, the calm that's spreading through your limbs, are exactly what the universe expects of you. Gentle release. Your breathing slows, matching the rhythm of distant tides, or the cosmic microwave hum still lingering from creation. Every exhale carries away a little structure, a little tension, and the world accepts it gratefully. The air, the sheets, the night itself, all of them become partners in your cooling, your quiet diffusion into the larger pattern. If stray thoughts arrive, let them drift. They're just molecules of memory looking for equilibrium. If an image from tonight's story lingers, a torchlit cave, a collapsing star, a single snowflake melting, let it fade as naturally as light sinking into dusk. You're safe in the same law that governs everything vast and small. The arrow of time is carrying you not toward loss, but toward rest. Every heartbeat is an echo of the universe's first expansion, every sigh a rehearsal for its final calm. So let go now. Let the warmth spread, the breath lengthen, the silence deepen. The fan hums like gravity itself, drawing you gently downward. The story continues without you needing to chase it. The universe keeps unfolding, and you, right here, are part of its perfect, peaceful exhale.